proceed ya. Sebenarnya settlement information. Okay, so right. Okay, so consolidation. Kalau ikutkan sebelum-sebelum ni exam memang masuk consolidation ni, primary dengan secondary. Tapi tengoklah, ikutlah awak lah sama ada ke tak. Okay. Dan selalunya it's not that easy juga. Alright, okay, so primary consolidation settlement relationship. So awak semua tahu when we have consolidation, it's when we have final soil material, okay, can be related to clay. Okay, so bila tanah tu tepu, okay, so bila ada loading, okay, so happens slowly. Occurs over time in saturated clay soils subjected to an increased load caused by construction of the foundation. On the basis of the one-dimensional consolidation settlement equations, we get SCP, okay, integration of apa nama benda ni, strain, okay, at z-axis, okay. So if we look carefully, okay, so ini adalah awak punya footing, okay, so this is Q0 where impose load daripada footing. Okay, and then the punya stress increase ni, okay, so it goes lower lah with depth. Okay, masuk ke atas is higher compared to the lower part. Okay, sebab after all your footing pun jauh daripada bahagian tanah yang kat bawah. Okay, so this is adalah clay layer. Okay, HC is the height of clay. Groundwater table, so ada groundwater effect. Okay, right, and these are the effect, the change in effective stress lah. Okay, alright, so kita akan lihat. So kalau tadi rumus dia ni adalah consolidation settlement, okay, where the vertical strain is given by strain Z equals to changes in E, okay, over 1 plus E0. Okay, E ni your void ratio lah. Okay, so E0 is your initial void ratio. Okay, so tanah clay, okay, so there are pores, very micro pores. Okay, so the micro pores awak ada initial void ratio, and then as your loading increases, it will give a change in your void ratio. Okay, so kita nak lihat macam mana perubahan ni. Okay, so taking the previous equations into account, okay, so ini adalah settlement consolidation settlement equation for normally consolidated clay. Okay, so if you want to understand this further, okay, awak sebenarnya dah belajar consolidation dalam geology, and then you can refer back to chapter 2 kalau dalam buku ni. Okay, so dia ada recap juga dalam buku DAS ni. Okay, untuk chapter 2, so there are consolidation chapter 2 ni semua ni lah soil properties. Okay, ada test, okay, awak pun dah buat dulu soil properties semua, including apa namanya, consolidation. Okay, alright, sekejap Okay, so that is the equation for normally consolidated clay. Okay, so kalau over consolidated means it has gone over time lah. Okay, so CHAC 1 plus E0 log effective stress not means initial effective stress plus change in effective stress AV. Okay, kejap. Aduh. Cakap apa? Settlement. Okay, so AV is average increase in effective pressure on the clay layer caused by the construction of the foundation. So average increase, okay, is AV. Okay, so kalau kita ada over consolidated clay, okay, so when your apa namanya, for OCR lah, so for OCR is more than 1, okay, so you have to include, okay, dekat sini, so you have your CS, okay, so your CS is your compression index, okay, compression index, okay, and then kalau over consolidated clay, for the other part, okay, you have to include CC, which is your compression index. Sorry, tadi CS ni adalah swelling index. Kita pakai note buku lah. Sekejap. Semua orang senyap je. Nampak ke slide saya?
Nampak Doktor.
Okay, alright. Okay, so kita kat primary consolidation. Okay, so ni yang saya dah cakap tadi. Okay, so okay, let's see. Okay, equation. Okay, sekejap mana tadi? Hello, ada kan? Okay. Okay, so kalau yang ni, okay, so if you look, okay, so for normally consolidated clay, okay, so SC consolidation settlement equals to HC plus 1 over E naught. Okay, so dia berbeza dengan the next equation. Okay, so awak pakai swelling index and compression index. Okay, so the second one for over consolidated clay with average effective stress. Okay, kat sini average effective stress, okay, on the clay layer before the construction of the foundation. Okay, plus dengan average increase in effective stress of the clay layer caused by the construction of the foundation. Okay, so kat sini, okay, you see the sigma prime C is the pre-consolidation pressure. So if the pre-consolidation pressure is higher, okay, larger than these two, okay, average effective stress dengan before the construction dengan during cost after the construction. Okay, so katakan kalau pre-consolidation pressure dia lagi besar, okay, so you use this equation where you just include swelling index. Okay, so swelling and compression ni dia hanya ada untuk clay soil. Okay, because clay soil is considered as expensive soil. Okay, bukannya expensive mahal tu, dia expensive. Okay, expensive soil maksudnya dia boleh expand. Okay, so clay soil ni, okay, dia boleh expand due to the the increase of stress and the conditions of the water and dia punya void. Okay, so that's why dia ada compression index, dia ada swelling index. Okay, so if, okay, for over consolidated clay, when the the initial stress, the pre-consolidation stress is lower than the other two, lower than the average stress before dengan average stress caused by the construction, then you use this equation. Okay, so this equation, as you can see, the difference is you have the CS ni masih sama, okay, but this one you have the compression index. Okay, so if your pre-consolidation pressure is lower, then you have to include your compression index. Okay, alright. So these are the three main equation that you have to calculate. Okay, so selalunya kalau soalan tu, normally you will go into over consolidated case. Okay, sometimes okay, maybe part A dia cakap okay, calculate for normally consolidated clay, and part B okay, calculate the over consolidated clay, but which condition? Okay, so awak kena tengok awaknya pre-consolidation pressure tu is it larger okay than your average effective stress before and caused by the construction. Okay, alright. Apa lagi? The procedure for determining compression and swelling were discussed in chapter 2. Ni awak boleh tengok balik kat chapter 2. Okay, so these are the the explanation untuk sambungan pada chapter 2 lah. Okay, so this is the average pressure, average effective pressure. Okay, alright. So that is for primary. Okay. Okay, so 3D kita tak ada sentuh 3D. I mean it's not for you. And then okay, so tapi itulah soalan dalam buku ni pun dia bagi yang ambil kira sampai ke 3D dimensional effect, which normally for your apa ni kita tak sampai lah for your level untuk test awak kita tak sampai 3D by right lah. But I think I might give you this one for interpolated values of KCR, OC. Okay, kejap. Patutnya tak ada. Okay, tak apa. In case I would like you to do assignment, okay, I might ask you to do assignment on this existing example. Okay, so you just have to restart to study and recalculate example 9.14, but you might have to learn ni lah on your own about the 3D. Okay, tapi it can be only assignment lah. Okay, dalam test ataupun quiz ataupun apa namanya ni shouldn't be ada 3D effect unless I tell you so lah. Okay, alright. So settlement due to secondary consolidation. Okay, so normally okay, so we calculate the primary, okay, and then we move to secondary consolidation. Okay. Okay, so secondary consolidation. Okay, so primary consolidation. Okay, jap. Saya habiskan ini tadi sikit. Okay, primary consolidation settlement relationship. Note that the increase in effective pressure on the clay layer is not constant with that. Okay, so this is bukan clay saja sebenarnya. Okay, apa-apa pun the effective pressure will never be the same for the same depth. Okay, but in clay it is very visible lah. The magnitude of that changes in effective stress will decrease with the increase in depth measured from the bottom of the foundation. So magnitude of changes in effective stress, okay, as you go down, okay, dia makin berkurang lah sebab dekat atas tu yang kena lebih dengan loading. Kalau if you are looking at into the loading effect, okay, alright. But kalau dekat bawah, it can be other things that affecting the the changes in stress. But if we look into the the effect of loading, then it will decrease as you go deeper. Okay, the average increase in pressure may be approximated by changes in sigma prime average stress equals to 1/6 delta T bukan data, changes in sigma T, changes in sigma M and sigma B. Okay, so all these T, M and B are respectively to the effective pressure increase at the top, in the middle and the bottom of the clay layer that are caused by the construction of the foundation. Okay, so dia bagikan into 3 section, which is the top, middle and bottom. Okay, alright, so this is the relationship for primary consolidation. Okay, so as we go to secondary consolidation settlement. Okay, so at the end of the primary consolidation, some settlement is observed that is due to the plastic adjustment of soil fabrics. Okay, so plastic means there's no changes in in volume. Alright. Okay, so this stage of consolidation is called secondary consolidation. A plot of deformation against the logarithm of time during secondary consolidation is practically linear, as shown in figure on the following slide. Okay, so this is your void ratio. So your void ratio, okay, as time increases, your void ratio will decreases. Okay, so variation of E with log T under a given load increment and definition of secondary compression index. Okay, so T1 and T2, as you can see, the void ratio, it doesn't, a plot of deformation against the logarithm of time during secondary consolidation is practically linear. Void ratio. Okay, so this explanation is for deformation. Okay, but this is for void ratio. So we don't say this linear lah. This is sigmoidal. Okay, sigmoidal tu graf dia bentuk S. Okay, so kalau awak tengok ni bentuk lebih kurang S. So you call it sigmoidal. Okay, so for void ratio, it is actually not linear. Okay, so this is the at the end we see the changes in E at different time. Okay. From the previous figure, the secondary compression index, okay, can be defined as, okay, in secondary consolidation, the compression index is no longer CC. Okay, kita get C alpha. Okay, so C alpha is secondary compression index. Okay, kalau tadi CC is compression index. Okay, so in C alpha equals to delta changes in E, which is changes in void ratio, over log T2 minus log T1. Okay, and then equals to log T2 over log T1 lah. Okay, so this is to calculate your secondary compression index. Okay, right. So from there, okay, the magnitude of secondary consolidation can be calculated as C alpha HC log T2 over T1. Okay, so C alpha A equals to CA over 1 plus EP. EP is at the end of primary consolidation. Okay, so we calculate secondary consolidation when your primary consolidation has stopped. Okay, so thickness of clay layer is HC lah. Tadi kalau awak ingat kedalaman HC tu, this one. Okay, alright. Okay, so okay, correlating CA with natural moisture content W of several soil, it appears that CA is 0.0001 W. Okay, this is just a correction factor. Okay, so bila ada moisture content, you have to when it comes to clay ni, all these researchers, all these people in geotechnics before, they have come up with correction factor. Okay, so dia dapat correction factor ni just to apply when the result is slightly inaccurate when the involvement of water. Okay, so semalam kalau awak ingat bila kita yang saya kata saya bagi assignment tu, okay, due to rise of water table in elastic settlement. Okay, kalau awak tengok yang semalam tu ada CW, your correction factor. Ada 3 CW. Mana? Sini ha. Okay, ada 3 tapi based on different people. Okay, so different people we come up with different equations. But by right, the answer shouldn't go very far. Okay, so dia dekat-dekat lah. Okay, so dia correction factor ni kalau yang semalam tu it still depends on DW and DF and B. Okay, so dW is depth of water, dF is depth of foundation, and B is your breadth. Okay, so it's just the different formula. Okay, alright. So but yang ini when you have water and then you have secondary consolidation, so it's actually more complicated lah daripada yang semalam tu. Okay, so also yang semalam tu CW, so here with secondary consolidation you have the correction factor in CA. Okay, so varies from 0.005 to 0.01. Okay, so ini adalah correction factor yang dia boleh guna. Okay, so for the magnitude, we have the organic clays. Okay, so it depends on different type of soil. Okay, ini adalah inorganic, this is organic, this is peat. Okay, so this is the magnitude of CA over CA over CC. Okay, ini bukan CA, ni C alpha kan. Ni C alpha sorry ya, dia tulis CA pula. Ni C alpha. But tiba-tiba kat sini jadi A pula. Okay, so it's actually C alpha. Okay, so C alpha is your secondary consolidation pressure. Okay, so secondary consolidation settlement is more important in the case of all organic and highly compressible inorganic soils. In over-consolidated inorganic clays, the secondary compression index is very small and of less practical significance. There are several factors that might affect the magnitude of secondary consolidation, some of which are not very clearly understood. Okay, so to be honest, okay, clay material is very unpredictable soil in terms of behavior. Okay, so that's why clay has a very wide behavior analysis compared to other soil lah. Okay, so katakan macam sand, okay, when it's dry, okay, it's very clear. Tapi clay ni, it becomes very complicated because it retains water. Okay, so bila tanah tu simpan air, tapi bila ada air dia ada juga void. Okay, and then dia ada juga dia punya apa dia panggil tu stress tu. Saya lupa yang dissipate tu over apa lah, sekejap. Saya dah lupa dah. You know when you compress soil with air, okay, so nanti dia akan ada overburden pressure. Okay, so the overburden pressure ni akan develop lah. Okay, in clay, especially when you impose loading. Okay, alright, so okay, so okay, let us ni lah briefly go through. Okay, untuk ni, tapi saya akan sentuh sikit je sebab yang ni ada dimension effect tu. Okay, so katakanlah a plan of foundation 1 times 2 times 1 times 2. Okay, selama ni itulah saya pun tak tahu kenapa chapter ni ke ataupun saya yang dah ni get confused. Apa selama ni B dengan L kita akan assume the longest is B. Tapi most of the example dalam ni kebanyakan dia terbalik lah. Ke selama ni saya cakap macam tu. Selama ni which one do you take the B? Is it the shortest or the longest? Can you recall? Anybody? Anyone? Hello?
Cik Doktor.
Ha?
Doktor, hari tu doktor kata yang panjang B.
Panjang B. Hari tu
Ya,
tu
betul.
semalam kan? Ke ataupun hari ke ataupun kelas-kelas lain?
Yang before this pun doktor kata yang panjang B.
Itulah sebenarnya by right is easier to assume that the longest is B. Okay, so okay, put that in your head first. Nanti saya akan update, okay, in case we change. Okay, but okay, kalau so in the example maybe kalau dalam test ke apa, kalau dia tak cakap, you assume at the moment the longest is B. Okay, but if dia dah cakap, awak follow lah. Kalau dia dah kata B bersamaan 2, so awak ambil lah B bersamaan 2. Janganlah awak cakap pula, oh no, because B should be longer. No. Okay, kalau dia dah bagi tahu, you follow in the test lah, or in any problem. Okay, so figure 9.33, estimate the consolidation settlement of the foundation taking into account the three-dimensional effect. Okay, so maybe kita try tengok settlement je dulu. Okay, consolidation settlement. Okay, so depth of foundation is 1. Depth of groundwater table is 1 tambah 1.5, so 2.5. Okay, so now you have your unit weight of sand. So you have your unit weight of saturated unit weight of sand. Okay, and then you have normally concentrated clay kat bawah. Okay, so your your consolidation awak nak kira mestilah untuk tanah clay itulah. Okay, so Q0 equals to 150, so that is your applied load, net stress increase. Okay, so solution is normally consolidated, so pakai rumus untuk normally consolidated. Okay, so CHAC 1 plus E0. So here they are just calculating your sigma prime naught from the equation 8.26. Okay, so you have to consider your top, middle and bottom. Okay, we divide the foundation into 4 quarters, compute the stress under a corner of each quarter using equation 8.10. Okay, and multiply by 4 for each quarter. B equals to 0.5 and L equals to 1.0. So B equals to 1.5, so then we half, and L equals to 1. Okay, so dia ambil half lah. So BL dia panjang tu. Okay, sebab dia nak compute under a corner of each quarter. Okay, so each corner of each quarter. Okay, so katakan quarter tu, okay, ada 4. Okay, so each corner of the quarter, so that's why divide half lah. Okay, so top location, location at the top, middle and bottom. So 2, so sini 2. Okay, so sorry, 2.5 2, 3.25 plus 4.5. Okay, so kalau sini sampai sini dah 2. Okay, so 2 tambah 1.25. Kalau 2.5 0.83. Okay, top bottom. Okay, alright. So okay, itulah sebab yang ini dia includekan dengan your punya 3D, which 3D effect masuk odometer. Odometer is one dimensional consolidation. Tak apa, okay, so ini masuk OED. Okay, so this part is already 3D. Okay, so I don't think this example is suitable. Okay, tak apalah, nanti saya maklumkan in case if you need to go on with this one, then we do some assignment on this one. But I doubt lah I would let you, sebab ni ada BEQ lagi. BEQ is not for you. Okay, alright. So I'm just trying to share the settlement sebenarnya, the consolidation, but because the primary and secondary is quite complex. Okay, alright. So I've shared the theory for this one. Let's see this one. Estimate the total consolidation settlement 5 years after the completion of the primary consolidation settlement. Okay, so 5 years after the completion of the primary. Okay, so kalau tengok example 9.15, they ask, given the clay layer C alpha equals 0.02, estimate the total consolidation. Okay, so figure example 9.15, it's So the secondary consolidation settlement is 0.02, which is your C alpha, but that is just secondary. What they want you to calculate is the whole primary and secondary. Okay, when the primary you have settlement after 5 years, so you have to calculate the settlement after for the secondary, and then you add on together. Note time for completion of primary settlement is 1.3. Okay, alright. Okay, total conciliation settlement is 36.3. Okay, alright. So I think if this one is related to your test, nanti saya akan do a video lah. Okay, I will add in a video and just watch the video lah. In case, okay, because I will check again, because I think this one is not necessary. Okay, you have to know about primary and secondary consolidation, but by right you just have to calculate using the primary consolidation of this equation yang 3 tadi. Okay, you don't have to do secondary untuk this one is important. Okay, you have to understand about the pre-consolidation pressure dengan comparison to average effective pressure. Okay. Alright, so okay, I think dah tak ada lagi dah kot. In case this one nanti saya will update. Okay, if it's needed, then you have to you have to learn from the video that I will do. Okay, so field load test is just consolidation test that you do in the field. Okay, tolerable settlement of building. Okay, this one I think I need you to do maybe assignment on writing lah. Tak nak writing. I need infographic. So you read this one nanti tolerable settlement of buildings, and you do in infographic. Maksudnya flow chart ke, nilai ke, apa ke. Okay. So alright. So because this is what we can do lah. Okay. Alright. So summary: rigid foundation settle uniformly, but the pressure applied to the ground is non-uniform. Okay. Flexible foundation apply uniform pressure to the ground, and the settlement is non-uniform. Okay. The immediate of elastic settlement of rigid foundation can be estimated as 93% of settlement beneath the center of the flexible foundation. Okay. Kalau awak tengok 93% ni, itulah yang semalam tu, okay, yang kena kali 0.93. Okay, so okay, so kindly get these two related to your settlement topic. Okay, alright. 0.93 ni ada dekat sini. 0.93. Kalau awak ingat bila saya cakap semalam yang bila awak kira rigid dengan rigid dengan flexible, okay, so it's actually a difference of 93%. Okay, so that's why you 0.93. Okay, so the elastic settlement of rigid foundation can be estimated as 93% of flexible settlement. Okay, alright. Any question?
Doktor. Infografik tu kita boleh buat dalam words or presentation mana je kan?
Boleh. I just need you to understand dan awak buat mind map ke macam tu, okay? Because settlement is very important, okay? Dia interrelated with many foundation topics, okay? Because you need to understand berapa settlement building kita, okay? I think this one is actually these limiting values are larger than those provided by the again pack, which suggests allow settlement limiting value. Okay, so saya rasa saya nak awak relatekan juga dengan our Malaysia punya limit untuk settlement. Tapi tu nantilah. I will put that in your assignment, or maybe it can come up in your test as well. Okay, any question?
Okay, Doktor, tu je daripada saya.
Tak ada. Okay, so saya sebenarnya dah wrap up untuk foundation bersama awak. Okay, so on Thursday, Dr. Anwar akan masuk, dan actually well, we have a lot of test quiz to be done, okay, to be conducted. Okay, so I think awak baru ada satu quiz, satu assignment, project tak ada. Project nanti dengan Dr. Anwar buat kan, baru satu quiz dan satu assignment.
Ya, betul.
Okay, alright. So nanti kita buat 2 test. Okay, saya sebenarnya propose one of the test is subjective, one of the test is MCQ, tapi we'll see how first. Okay, if we can carry out your test in MCQ, sebab dia banyak MCQ sini lagi bahaya daripada subjektif, sebab katakan kalau awak salah lah. Okay, dia tak ada, awak boleh nak goreng-goreng ke, nak cuba-cuba kira benda lain ke, boleh dapat 1-2 markah. Tak boleh lah. Okay, so ada apa-apa soalan?
Tak ada,
Doktor.
Yes.
Nak tanya lepas ni slide tu dan assignment tu hantar dekat UCAM folio ke?
Semua kat UCAM folio. Saya tak update je, sorry lah. Ya, betul. Everything is UCAM folio. Okay?
Okay, thank you Doktor.
Okay. Nanti saya update nota. Lepas tu test, quiz macam biasa. Quiz memang UCAM folio. Assignment UCAM folio. You will have to submit assignment UCAM folio. Test UCAM folio. Kalau MCQ confirm UCAM folio. Kalau subjektif, inilah, awak ambil soalan daripada UCAM folio dan awak buka kamera dan awak jawab lah dalam masa 2 atau 3 jam. Okay, nanti akan ada ada invigilator yang akan tengok awak. Okay, bukan saya lah. I cannot sit for 3 hours and just watch you to answer your question. Okay, alright. Kalau dah tak ada apa-apa, kita endkan kelas kita kat sini. Is that okay?
Okay, boleh Doktor.
Okay, Doktor.
Alright. So I will still see you in IDP. Okay. And tak ada dalam kod dengan cuma markah. Inilah markah nantilah. Untuk maksud saya untuk assessment for this one. IDP je lah kan, saya jumpa awak lagi. Okay, terima kasih semua. I hope that the course is okay. Okay, katakan kalau saya ada hutang mana-mana soalan yang tak terjawab, ya, kindly ni ingatkan saya dan saya akan try to explain by video or saya add on files in UCAM folio. Kalau ada mana-mana saya hutang yang saya belum jawab. Okay, boleh?
Boleh Doktor.
Alright, okay. Okay, so take care. Assalamualaikum and see you guys. Dan selamat tengah hari. Bye.
Bye.
Thank you Doktor.
Thank you, Doktor.
Thank you, Doktor.
Doktor.
Thank you, Doctor.